Hello everybody, welcome back. So last time we left off, we were creating a breakout game, and what we had was this ball that can bounce around, but it doesn't collide with the bricks or the player. So we're going to add these collisions. And I think that will probably be good enough for today. One of the things that I did, I made just a slight change to the main function, is I commented out full screen and I set the window size to 1920 by 1080. So that way we could see the screen that we have, right? So that way we can essentially do some debugging, and we can do some printer debugging. So that way when we run the program, we can actually take a look at our little terminal screen. Okay, so what we're going to do is we're going to add some collisions. So let's go ahead and do these collisions with the bricks first. So what we'll do is we'll say collision type is going to be collision with the ball and the brick. Okay, and then we'll say if the collision is above, then what we'll do is, let's see, with the brick. So we want to collide with every side of the brick, because it's going to be possible to do this. So we're going to say if it's above or C type is below, then we're going to reverse the ball direction. So B dy is going to be -1 times B dy. And then if the C type, let's just grab this. If it's left or right, so let's do left or right, then we'll reverse the X direction from whatever it was before. Also, let's see here. Let's go to, there's one other thing I realized, and that is the player. So the player, do I have the player? So what I did with the player was, originally our collider had 50 and 50 as the size of the player, but our player is not 50 by 50 anymore. Our player is 120 by 25. So I made that little tiny change, so that way our collider works properly. So we have this ball, and I believe that should be good enough. Let's see, wait. And C type, equals below. Of course. So let's do that. We'll see if we build without errors. So now it should collide with, yes. So we're still not colliding with the player, but we are colliding with the bricks. So the next thing that we want to do with the bricks is we want to deactivate the brick, right? So let's go ahead and do that. Now, the thing to think about here is that this brick is a value base. So we can't change that because it's not a reference. So let's go ahead and use I here. And we'll say if there is a collision, we'll say scene bricks I active equals false. And we'll use this same idea here. Let's see, we'll copy and paste it in. Now, so that should deactivate the brick. Now, the only other thing that we have to do now is if there is a collision, or if the brick is not active, we don't need to do any of this, right? If the brick does not exist anymore, we shouldn't do that. So let's check for that. If brick active, actually, if the brick is not active, let's just continue our loop. So we'll do continue. We'll do a build, and we'll do breakout. And so now, well, actually, it doesn't matter that, but now the bricks should break. The brick should disappear. And so as it collides, it should do more of these bricks. So we can see, hopefully we'll get more of like hit from the side. Ah, yes, we've hit from the side. That's good. Boom, boom. Okay, yeah, we're hitting all the sides of the bricks. So now that we've got the brick collision, let's add the player collision, which should be pretty easy. So let's say if a collision between the ball and the scene player is above, then what we'll do is we will reverse b dy equals -1 b dy. Okay, so that should be all we need for collision with the player. Okay, so now we're colliding with the player. We're colliding with the bricks. Now, the interesting thing about this is that the game will play exactly the same every single time, because you'll notice that we're just reversing the velocity off of the ball. And we would like the player to have more control over where the ball goes. And so what we want to do, I'm thinking what we'll do here is we'll calculate essentially the angle that the ball is hitting the platform. And then what we'll do is we'll actually change that angle just a bit, right? So basically, if it hits to the right side of the platform, then the velocity of the ball gets rotated a little bit to the right. And if it hits to the left side of the platform, it gets rotated a little bit to the left. And so this will allow us as the player to control essentially where the ball is pointed over time. So what we're going to need to do is we're going to end up using some math, some trigonometric equations. So we're gonna import math, and then down at the bottom here, we're going to add some functions. All the trigonometric functions require radians. So we're going to have some conversion functions of degrees to radians, and then radians to degrees. We'll say float. All these are float 32s, but we'll return a float. We'll return a float 32. Okay. No, actually, yeah, we'll return a float 64, so that way we can do stuff with it. Okay, function radians to degrees, radians float 64 and float 32 out the other end. So that way, because all of our stuff uses float 32s. So what we'll do is this will return, what is this? Degrees times math pi over 180. And then return, now the opposite of this is radians. I think it's, what is it? I looked it up actually. Oh, radians times 180 over pi. So yeah, radians times 180 divided by math.pi. Now, the only thing that we'll have to do is get our types to be set properly. So we're going to return a float 64. So that means this is going to be a float 64. And let's just make sure that all of this, it knows that this is supposed to be a float 64. So float 64 radians. Radians already is guaranteed to be a float 64. I think this is okay. We just need to convert all of this to a float 32 at the very end. Okay. There we go. So that's pretty good. So now we have those functions. The next thing that we need to do is we need to be able to calculate the angle of incidence that we need. And so this will be the calc angle. And then we'll say dy dx float 32, turn a float 32. And what we'll do here is we need to get return math. Oh, you know what? Let's do a float 64 because we're going to end up doing trigonometric functions with this. So we're going to calculate this angle, and we're going to say math a tan 2. I think most libraries have arctangent a tan 2. Okay, yeah, most libraries have this arctangent. What arctangent does is if you give it a y and an x value, it will return essentially the angle that comes out of this. And so that will be in radians. So we'll get dy dx. There we go. In fact, we'll just call this y and x. That'll be fine. Y and x. It's fine. So that will give us the angle that from this thing. And so then what we'll do is we'll actually recalculate this angle. Oh, we also need to calc velocity. And we'll say dx dy float 32. And we'll return a float 32. And this is return math square root. This should be the square root of dx dx plus dy dy. Okay. So that gives us the velocity from essentially those two vectors, right? Those two speeds that we have. That'll give us a velocity. And then we will decompose velocity. And so the way that we can decompose the velocity is we'll give it a velocity, v for velocity, and it'll be a float 32, and we'll return float 32, float 32. So it'll return a dx and dy for us. So we should be able to return, let's see, so decompose the velocity. So if the velocity is, oh, this and an angle. Okay, so we've got an angle and a velocity. We should be able to have, let's see, so let's say dx, we may be able to just return this all in one, but we're going to say, so that angle is in, let's write some comments for this. Decompose velocity returns the dx and dy speeds from the given velocity pixels per frame and angle, which is radians. Okay, so now let's see. What we're going to do is we're going to say that I believe we can get the x component by doing the cosine. So we'll say, yeah, actually, okay, let's return velocity times math cosine of angle. And this should be the velocity times math sine of the angle. It's been a while since I've done some of this trig, but I believe that's what those components are. Okay, so that decomposes the velocity. So those are essentially the functions that we need, right? So if we collide with the player, what we're going to want to do after this is we're going to want to get the angle by doing calc angle from b dx, b dy. So that gives us an angle in float 64 in radians. Then what we want to do is we want to slightly move that angle one way or the other. And so what we're going to do is we're going to say we're going to calculate, we need to calculate the center X position of the ball and the platform, the player. And then we're going to see how far the ball is from the center of that platform, right? And then we'll say the further it is from the center, the more we're going to rotate that velocity. So let's say player center X is going to be scene player position X. And then, of course, that X is the leftmost part, so we're going to add half of the player's size. And then we're going to have ball center X, which is the ball position X plus 5, because I think the ball is of size 10. So now that we've got those, we can get a distance in pixels of one from the other. So we're going to say the player center X minus the ball center X. And that gives us a distance in pixels. And then what we'll want to do is convert that into an angle that we want to do. So how much do we want to rotate this velocity? I'm going to say the maximum that we want to do is maybe 10 degrees to the left or 10 degrees to the right. Notice that the player center X minus the ball center will give us either a positive or negative value. So what we're going to do is we're going to take this distance and we're going to say we want how many degrees there can be. So we're going to say the rotation that we want to add to this is going to be, let's see, how many degrees divided by the max number of pixels. So we'll say the degrees. So we'll say 10 degrees divided by the max number of distance that we can have, which is 60. So really, let's simplify the fraction. So 1/6, and then we multiply that by the actual number of pixels that we have. And so there we go. That should be the rotation that we get to the other thing. So new angle is going to be the angle plus the rotation. Right? So that's the new angle. So now we will get a new dx and new dy. So we'll say ball dx, ball dy is going to be the decomposed velocity. And, oh, we need to get the velocity. So velocity is calc velocity, and this will be b dx, b dy. And so what we'll do is we'll get a velocity, and then we have a new angle. Now we could shorten this up a bit, but for now it's kind of nice to have it all just laid out for us. So this should be the new velocity that we have. Now the only thing that we want out of this, though, is that's the new velocity, but we want, this is a collision, right? So we want the y velocity to be reversed. So let's do b dy equals -1 b dy. So first what we did is we rotated the velocity. So rotate the velocity. And then reflect or bounce. Bounce the ball. The other thing that we probably should do is to ensure that it just doesn't rotate out of craziness. We need to make sure that when this ball bounces, it's actually above, let's say 1 pixel above the platform. Otherwise, if it's going fast enough, it'll be inside the platform. And then as it's coming back out, it'll rotate even more. We only want it to rotate once. So let's see. We need to say B position Y needs to be the the scene player position Y, and then we're going to subtract B size Y, and then we'll subtract 1 from it. So that way we basically have the platform position, and we're going to put the ball at that platform position, but move it up by the size of the ball, and then move it up 1 more pixel. So that way we don't accidentally run into the platform. Okay, so that should be that. That's a lot of work. Let's see what we've got here. So we've got 1 error, BDY. Oh, whoops. Never mind. There we go. So we just have to have that be a multiplication. Okay, there's a bunch of things actually. So let's do this. This makes sense. Okay, so angle plus rotation. So this angle that came out, calculate angle. It returns a float 64, and the rotation, oh, distance. Yeah, okay. That makes sense. So float 64 and float 32, yeah. Float 64. That's what this should be. I think that will fix a bunch of things because angle and rotation should be fine now. So if we clear that out, see what else that we have. Cannot use Y, variable float 32, float 64 and to ATAN2. Oh yes, I forgot. We have to make sure that all of our variables have the correct types. So that will take care of a couple of errors there. And we should only have a few left. Oh, these are, yes, math square root also wants those things to be float 64. The entire math library lives on float 64s. So let's see. That should save a couple more. Oh, what's going on? Math square root value as float 32 in type return statement. Oh, yes. This is kind of funny. Because I want the velocity. Wait, do I really want the velocity to be? Do I want the velocity? Decompose velocity. Decompose velocity. You know what? Actually, let's. You know what? Let's have both the velocity and the angle be float 64s. Yeah. So that way the velocity will be a 64. And when we calculate the velocity, you know what? Let's not worry about this. Let's return a float 64. That should get us most of the way there. And then I'm just missing some kind of... Okay, so float 64 square root. Boom. Okay, wait. Can I use velocity? Oh, decompose. Wait. Decompose. Wait, decompose. Wait, calc velocity I thought returned... Oh, calc velocity is supposed to return float 64. There we go. So the biggest part, and of course this is a wonderful thing, is the static type checking. It saves you a lot of problems. Okay, so cannot use value of float 64 as float 32 in return statement. Ah, yes, that is correct. Float 32, and this will also be a float 32. That should be most everything. Okay. Ah! Okay, we missed it. Okay, that isn't quite what I wanted, but boom. Okay, that's nice. We'll have to make the velocity a little bit higher, but oh, darn it. Okay, yeah, the velocity. Okay, we want to rotate it. I want to rotate it. Oh, jeez. Huh. Okay, so obviously there's a bug here. That did rotate it fairly to the right. Oh, whoops. This is tricky. Okay. Boom. That rotated off to the right. Boom. That's interesting. Okay. Okay, so obviously it's not exactly what we want, but it does kind of what we want, right? It's not. I kind of wonder, probably we'll do a third part to this to kind of fix this out, but this actually does mostly what we want. It just has a couple little bugs, right? So I'll take a look at this real quick, and then we'll probably stop. Let's see, bricks, collision with the player. And so what we'll do is we'll say log println, and we're going to say, so we know that there's a collision. We're just going to show a bunch of these things. We're going to have this angle. There is distance. There is rotation. New angle. And velocity. Okay. So this, we're going to use this next time to figure out what's going on, right? Because essentially have an angle, right? A distance, a rotation, which is 5 degrees, a new angle. Wait. Oh, a rotation which is 5 radians? That seems huge. Okay, so we definitely probably have calculate angle, math a tan 2, xy. Let's see what this is. Angle, player, distance. Oh. So this is, this is a rotation in degrees. That's a rotation in degrees. We need to do degrees to radians. No wonder it was huge. That might give us just a little bit better behavior just right off the bat. Oh. Oh, that's not quite what we wanted. But it's better. It's better than what we wanted. Okay, so we had an angle of 7, distance 25, rotation of this. So that one seemed fine. I should have the old velocity and then the new velocity, right? So this one has an angle of negative, a rotation of 0.1. That one seems fine. This one has an angle of 1 almost. 1 radian. And then a distance, rotation of this, radians, new angle, is just over 1 and velocity. So what about this one? Angle half, rotation 0.09. Actually, all of these seem relatively reasonable. So maybe we just need to reduce the amount of rotation that we want to have. Okay. So yeah, so we'll take a look at this. Actually, we'll take a look at this again. I didn't mean to close everything, but we'll take a look at this again next time. Because this will actually be really interesting to look at. And I think it should be pretty fun to do. So let's see, 05 breakout. This, like, it should be really interesting to look at, because that shouldn't happen. That was just really weird, right? Because we have an angle of negative 0.07 radians. Maybe I'm calculating this a little bit wrong. Or maybe I need to figure out what quadrant it needs to be in and, like, flip it. Because let's see, distance is actually almost 0, right? So rotation, very little. New angle, 0.7. So all this seems reasonable. I just think that the angle that I'm calculating probably isn't the best. Because what we'll do before this is we'll say log println old dx. Oh. Yeah, I actually decomposed the velocity up there. So what we'll do is we'll say old dx up here. Log println old dx bdx old dy bdy. There we go. So then we'll say new dx. Oh, and this is, yeah, that should be fine. No, wait. Down here. In fact, we'll just print all of this down here. All right? So we'll take this, paste it here. That can go down. And then we'll say log println new dx new dy. And there, this will allow us to figure out what's going on essentially after each collision. So we'll be able to build and just do a bunch of different stuff here. I probably am missing, log. Angular rotation, velocity. Wait, what? Unexpected name log at end of statement. Wait. Strain. What? Log println. I mean, this is angle new dx bdx bdy. New angle velocity. What? Oh, am I missing a... Huh. Well, we'll figure this out next time. I mean, this will get us what we need for some of these things, right? Because, yeah, that'll be good. Okay, cool. Yeah, so that'll be good. So next time we'll take a look at this, and we'll get this rotation thing done, and then we'll essentially mostly be done. We'll probably what we'll want to do is create a little splash screen saying that you won or lost, and that'll be essentially a complete game. And then once we have that, we can actually build more games off of it that and reuse a lot of this code. So, all right, till next time.